Hello and welcome to my channel Learn, Grow and Succeed. Today is lecture 2 for class 12 physics. So let's get started and look at the topics for today. In the previous part, we did electrical capacitance of an isolated spherical conductor. And today we will do capacitor and principle of a capacitor. Okay, so first question is what is a capacitor? First of all, we will write its definition. A capacitor is a system of two conductors system of two conductors placed close to each other placed close to each other separated by an insulating material. Okay, separated by an insulating material and used for storing large amount of charge. Okay, so this diagram represents a capacitor. Here we have two conductors, conductor A and conductor B, placed close to each other and separated by insulating material. The plate B is earth. Okay, so how does it work? Let a charge plus Q is given to plate A and suppose the plate B is not near it, is not present here. Okay, so a point will come when the the plate A will be fully charged and further charge given it to will be leak out. So it has fixed capacity to store charge. So if we bring near plate B or conductor B, then induced charges will be produced on its faces. Negative charge will be induced on its inner face and positive induced charge will be induced on its further face. Okay. So due to this negative charge, the potential of the प्लेट ए इज समवट डिक्रीज्ड ए का पोटेंशियल थोड़ा डिक्रीज हो जाएगा नेगेटिव चार्ज की वजह से अब क्योंकि पॉजिटिव चार्ज नेगेटिव चार्ज से थोड़ा दूर है इसलिए इसका इम्पैक्ट थोड़ा ज्यादा होगा अब फर्दर जब हम प्लेट बी को अर्थ कर देते हैं व्हेन द प्लेट बी इज अर्थ द पॉजिटिव चार्ज flows to the earth so now the plate b is with only negative charge okay so due to this negative charge on plate b the potential of A is sufficiently increased. अब इसका पोटेंशियल इंक्रीज हो गया है तो इट मींस हम इसको और चार्ज जो अब दे सकते हैं पोटेंशियल डिक्रीज हो गया है तो इसको हम और चार्ज दे सकते हैं टू रेज इस पोटेंशियल टू द मैक्सिमम अगेन ओके इट मींस we can store more charge in this system in the system of two conductors A and B okay so this is the arrangement of a capacitor. Now we will look into its principle. Next is प्रिंसिपल ऑफ अ कैपेसिटर। कैपेसिटर, तो अभी हमने देखा कि जब हम एक इंसुलेटेड कंडक्टर के नजदीक एक दूसरा अनचार्ज कंडक्टर लेकर आते हैं तो उसका पोटेंशियल जो है वो डिक्रीज हो जाता है, जिसकी वजह से उसमें और चार्ज जो है वो अब हम स्टोर कर सकते हैं। तो यही चीज जो है कैपेसिटर की का प्रिंसिपल है। ठीक है, तो हम लिखेंगे प्रिंसिपल ऑफ कैपेसिटर में कि द पोटेंशियल of an insulated charged conductor insulated charged conductor is sufficiently reduced or decreased, and its capacity and its capacity is increased by bringing near it another uncharged uncharged earth conductor. Okay, this is the principle of a capacitor. ठीक है, now our next topic is capacitance of a capacitance of a parallel plate capacitor. Parallel plate capacitor. Okay, plate capacitor. What is a parallel plate capacitor? A parallel plate capacitor, a parallel plate capacitor consists of two metal plates, two metal plates A and B, which are held parallel to each other, which are held parallel to each other. ओके, कुछ इस तरह से होगा। दो पैरेलल प्लेट्स, मेटल प्लेट्स होंगी ए एंड बी, जैसा हमने पिछले टॉपिक में पढ़ा था जब हमने प्रिंसिपल ऑफ कैपेसिटर किया था। ओके, तो ये पैरेलल प्लेट कैपेसिटर की अरेंजमेंट है जिसमें दो पैरेलल प्लेट्स हैं कंडक्टर की, इनको एक दूसरे के नजदीक रखा गया है और एक प्लेट जो है वो अर्थ होगी। जब हम ए को चार्ज प्लस पॉजिटिव चार्ज देंगे तो बी पर इंड्यूस चार्जेस प्रोड्यूस होंगे, नियरर फेस पर नेगेटिव चार्ज, फर्दर फेस पर पॉजिटिव चार्ज। अब क्योंकि प्लेट बी अर्थ है so all the positive charge flows to earth. So we have plate A with positive charge and plate B with negative charge. It means के दो कंडक्टर्स के बीच में इलेक्ट्रिक फील्ड हो जाएगी। ठीक है, एक पे पॉजिटिव चार्ज है, एक पर नेगेटिव चार्ज है। ओके, तो इसको लिख लेते हैं। When plus Q charge is given to plate A, induced charges minus Q and plus Q are induced on nearer and farther face of plate B. Since plate B is earth, hence all the positive charge, all the positive charge flows to earth, flows to earth, and plate A is left with charge plus Q and plate B with charge minus Q. Okay? Hence, an electric field exists between A and B. Hence, hence an electric field exists between A and B. Okay? So, this electric field is given by E is equal to sigma upon epsilon naught. In chapter 2, we have already done it. Electric field between two metal plates. Okay? So, it is E is equal to epsilon upon, sigma upon epsilon naught. Okay? Now, if V is the potential difference, if V is the potential difference between plates A and B, then we know that E is equal to V upon D, where what is D? D is separation between the plates, distance between the plates, separation between the plates, separation between the plates. Okay, so this distance is D. Okay, now we have E is equal to V upon D, or V is equal to ED. Okay, and we know that E is equal to sigma upon epsilon naught. So V is equal to sigma upon epsilon naught into D. So what is sigma? Sigma is charge density, and it is given by charge per unit area, Q upon A. Okay, so we can write V is equal to Q upon A epsilon naught into D. Okay, so we know that we now have potential. We know that Q is the charge. So now we can calculate the capacitance. Okay, hence capacitance of parallel plate capacitor is given by, what is the formula of capacitance? C is equal to Q upon V. Here, sorry, here Q is equal to small q and V is equal to Q upon A epsilon naught D. Therefore, capacitance will be equal to Q upon Q upon A epsilon naught into D. We can cut Q from Q. So we are left with C is equal to epsilon naught A upon D. So this is the required expression for the capacitance of a parallel plate capacitor. Okay, so I hope you have understand this topic. So we will meet in the next class.